Okay, we are in grade 10, and in grade 10 we are doing mathematics. We are going to be looking at revisions. Okay. Now, if you are going to write an exam, this is for you. Okay. Let's have one question. Let's say you are given fractions, and then you are asked to write equivalent fractions. Basically, our first question is on equivalent fractions. Okay, on equivalent fractions. Now, um, um, let's say, okay, equivalent. This is our what we are going to revise. Okay. Now, what are equivalent fractions? Let me say you are asked to write um, the following fraction as equivalent fraction, and I want to add and say with denominators 100. Okay. Let's say we have this fraction, all right, and then you want to write an equivalent fraction here with denominator 100. So what do you know? We know that this number here, this one, is the numerator, and this one is the denominator. Okay, the numerator, the denominator. Now, if you want to make the denominator 100, what do you do? All you need to do is to say, okay, I multiply 10 by 10 so that I get 100. Okay, as my denominator. Now, if you multiply by 10 in the denominator, you just have to multiply by 10 in the numerator to balance. So that means 3 times 10 is going to be 30. Okay? So 30 over 100 is equivalent to 3 over 10. They are equivalent, meaning they are equal. It's just that one fraction is more simplified than this one. This one is not simplified, but this one is simplified. But the two fractions are equal. Okay? Let's look at another one. Let's say we have this one. Let's say we have this one. Okay? We have this one. This fraction here. Let's say it's 7 over 20. And then you want to write an equivalent fraction with the denominator 100. What do you do? Okay? I know some of you have already found the answer. Okay? We want to make the denominator 100, so to make 20 100, you can multiply 20 by 5. So you multiply also 7 by 5 to balance our fraction. So it becomes 20 by 5 is 100. And then what we have, 7 by 5 is 35. So that means 35 over 100 is equivalent to 7 over 20. Okay? Yes, that's basically what we mean when we talk of equivalent fractions. Okay? We still have more examples to look at. Let's look at 9 over 50. 9 over 50. All right? As an equivalent fraction, what are we going to have? Okay. What are we going to have? I know some of you are already they are already comfortable now with this. So let's make the denominator 100 still. So we multiply by 2 so that 50 by 2 is 100. We multiply by 2 on the numerator to balance. Okay. So what you do on the denominator, you do the same on the numerator. So 2 times 9 is 18. 2 times 50 is 100. So you have 18 over 100. Okay? Now, let's continue and say we have another example. We have another example. And then in this example, we have, let's say, uh, 4 over 5. Equivalent fraction with the denominator 100 would be what? We just multiply. To make 500, you multiply it by 20. Okay? So what do you do or to 4? You multiply 4 by 20 to balance. Okay? So then what do you have? 5 times 20 is 100. 4 times 20 is what? 80. So 80 over 100 is equivalent to 4 over 5. So there is something that is important. We are dealing with multiplication when we are talking about equivalent fractions. You will deal with multiplication. You either multiply or divide. Okay? You either multiply or divide. Okay? You either multiply or divide, because when we move from 4 over 5 to 80 over 100, we multiplied both the numerator and the denominator by 20. But if we were moving from 80 over 100 to 4 over 5, we would divide the denominator by 20, and we would divide the numerator by 20 and the denominator by 20. Divide. Now, meaning you multiply when you go to a seemingly bigger fraction, and you divide when you move to simplification. When you simplify a fraction, you divide. Okay? Now let's look at another example here. Let's say we have what 1 over 2. Okay? If you have 1 over 2 and you want to write an equivalent fraction with 100 as the denominator, then we would say, okay, to make 200, we multiply by 50. So since we have multiplied by 50 on the denominator, we will have to multiply by 50 on the numerator to balance our fraction. So denominator becomes 1 times 50, which is 50. Okay? Then the denominator becomes 2 times 50, which is 100. So 50 over 100 is equivalent to half. Okay? That is that. So now, with equivalent fraction, that's what you can do. Okay? Now, let's move to another part of our revision. I will call it part 2. Okay? I will just call it part 2, whereby we are going to be looking at basic operations. Basic operations. It's a topic on its own. Basic operations. When you talk of the basic operations in maths, we are talking about actually addition, subtraction, multiplication, and division. So we apply this. These are the basic operations in mathematics. We operate types of numbers with addition. So the type we could be dealing with say you are dealing with decimal numbers. You are adding decimal numbers, or you are subtracting decimal numbers, or you are multiplying decimal numbers, or you are dividing decimal numbers. Or fractions. Adding fractions, subtracting fractions, multiplying fractions, dividing fractions. So that's what we normally mean when you talk of basic operations. But now I want us to focus on decimal numbers. Okay. Now let's say you have to work out this number. You just have to work it out. Okay. The question says work out 0.0 0.73, okay, times 100. How do you work this out? 0.73 times 100. So you are multiplying by 100 here. That's very important. So when you multiply a decimal number by, say, 10, 100, 1000, okay, 10,000, okay, okay. So you are multiplying by factors of 10 or powers of 10. What you do is just to, if you are multiplying, you are going to move the decimal point to the right. Move the decimal point to the right. How many times you move it? How many steps you move it? The number of zeros step. So if you multiply a decimal number by 10, you are going to move a decimal point one step to the right. You multiply a decimal number by 100, you are going to move a decimal point two steps to the right. Why? Because there are two zeros on 100. One step to the right here because there is one zero. That means here you are going to move it three steps. Here four steps. So let's do it. Now, because we have this, we will have to move our decimal point here. It's here. This is the decimal point, this one. So we are going to move it because we multiply by 100. Then on 100 there are two zeros. We are going to move it two times or two steps to the right just because we are multiplying. So it will be 1, 2. So the decimal point will come here. It will move from here to here. So that means we no longer have 0.73 but 73.0. So we can leave it as this 73.0. Let's just leave it like this. So this would be the answer. Or you can just say 73. Okay? All right. Now, um, mm, let's look at example number 2. Let's say we have um, uh, 0.062, okay, and then this now is multiplied by say by 100. Okay, let me just say by 10. Okay, so you multiply this by 10. So what are you going to do? You are going to say, okay, if I multiply by 10, there is one zero, so I'm going to move my point one step. Because I'm multiplying, I move it to the right. So it will move from here one step to the right. So the answer would be, instead of 0.062, the answer becomes 0.62. 0.62. This is the answer. All right? Now, this is simple mathematics, but very critical if you are not grounded, right? Now, let's continue. Let's continue. Let's look at example number 3, whereby you have 1.2 divided by 100. 1.2 divided by 100. Okay. What do you do? You are dividing by 100. When you divide by the power of 100, or powers of 10, 100 is 10 to the power 2. Okay. 1000 is 10 to the power 3. 10,000 is 10 to the power 4. So when you multiply or divide by the powers of 100, and that's you are dividing or multiplying a decimal number, you are just going to move the decimal point. This is the decimal point. So here, because we are dividing by 100, there are 1, 2 zeros. The decimal point is going to move 2 steps. But the direction is going to be to the left when we divide. It moves to the left. When we multiply, it moves to the right. When we divide, it moves to the left. Okay? So now, let's see. We divide by 100, so the decimal point will move 2 steps to the left. 1, 2. it will be somewhere here. Okay, so what do we do? What we do is to say, okay, we have moved the decimal point from here 1 2 steps. That means it's going to be somewhere here. Okay, what do we do for this position? We just place a 0. So we are going to have the answer as 0 point, this one, 0 1 2 as the answer. Okay, we couldn't just say the point has moved from 1 to here. We couldn't just say point 0 1 2. Okay, point 0 1 2. Usually you must put a 0 here to make it look smart. All right. Okay. Okay. All right. Let's see another question. Now, we may have a situation. Let's say for we may have 5.73 divided by 10. So you divide by 10, that means the point is going to move 1 step. Because you divide, it will move to the left. Yeah. So this becomes the decimal point will move from here 1 step to the left. Why 1 step? Because there is 1 0. Why to the left? Because you divide. So you are going to have 0.573. To make it smart, add 0 here so that it's 0.573. That would be the answer there. All right. Let's look at this one. Let's look at this one now. Say you have 2.51, okay, divided by 20. Okay. Now you divide by 20 here, but 20 is not actually 10. If it were 10 here, we would just move the point 1 step to the left. But because it's 20, we can't just move this point. We have to break this 20 into 10 times 2 first. Okay, so it becomes, you just have to be wise. It becomes, you can say it becomes 2.51, okay, divided by, this is what I usually do, divided by what? Divided by 10 times 2. Okay? That's what you do. You have just write it like this because it's going to be easy when you present it like this. 2.51 divided by 20, but 20 is 10 times 2. Then this becomes this. 2.51 divided by 10 times 1 over 2. It's the same. It's the same, okay? So we have separated them because we want to deal with this first. Division by 10, which will make us move this point this way, okay? So what do we do? What we do is we can even say, okay, let's say 2 goes once in here, and in here 2 goes once. In here it goes twice, leaves 1. Okay, there is a point. So in here in 11 it goes how many times? 5. Okay, we can just do that. We can just simplify it like that. So what we do, what we have, it's we have 2.51 divided by 2. We can just divide it by 2 right there, so that we have 1.255. Okay, because it's 5, it leaves 1 again. 2 into 1 doesn't go, we add 0. 2 into 10 goes 5 times. So we have this, we have 1.255 255 divided by 10. So when we divide by 10, we are going to move the decimal point to the right. How many times? One time. One time. 1. So we are going to have the answer as 0.1255. So we can put a 0 to make it appear smart. All right. So that is how you do it. That's how you do it. Now, let's look at this one. Let's look at this one. Let's look at this one. Okay. Let's look at this one. How do you work out this one? Let's say you had this. You had 0.32, okay, 0.32 now time is 300, okay, time is 300. What do we do? You are multiplying by 300, not by 100. So let's make it 100 by 3. So you can say I have this. You can say I have this. I have 0.32 times, let's break this into 100 times 3. So we can focus on this. 0.32 times 100, the point will just move, okay? The point will just move. This point will move to the right 2 times. 1, 2. It comes here. So you have 32.0 times 3. We are done with 100. Now we bring down the 3. Don't forget this. Times 3. We bring it down here. Okay? Now, so here it's easy. 3 times 0 is 0. 3 times 2 is 6. Then 3 times 3 is 9. So the answer is 96 here. Okay? That's it. That's how you do this one. Okay. Now let's look at this one. There is one interesting part on this this exercise. Let's say we have this one. Let's say we have this one. We have this one. We have 0.1 times 0.03. Okay? How do you work out this one? Okay, sometimes you can just this is what you do. This is what you do. You can just say, okay, I have 0.1 times 0.03. Okay, so you can just say, okay, how many decimal places are here? There is 1. How many decimal places are here? There is 2. So the sum of these decimal places is 3. That means your answer is going to have 3 decimal places. Okay? Now, let's say 3 times 1, that is 3. 3 times 0, that is 0. You see? Now, because of these 3 decimal place, your answer must have 3 decimal place. So you can say, to make it 3 decimal place, you will add 0 here, 0.003. Now, that would be your answer for this one. Or if you don't mind, you could just say, okay, this becomes, you convert this to fractions. You can say, okay, that becomes 1 over 10 times 3 over 100. Okay? Then you say 1 times 3, it would give you 3 over 10 times 100, which is 1000. That means you have 3 over 1000. So what happens? If you divide 3 by 1000, you know 3 is 3.0 actual. There is a point here. So you are going to move this point 3 steps to the left. 1, 2, 3. The point would be here. So you put a 0 here, a 0 here to keep the positions. Then that means ultimately you have 0.003, which can be written as 0.003. Okay? Yeah. Now let's look at the last example here. Let's say you have 0. You have 0.004, and you have to divide it by 0.2. What do you do in this case? All right, you can just write it like this. You can just write it like this to make it easy. You can write it as 0.004 divided by 0.2. So you cannot, it's difficult to divide with a decimal number. So let's destroy the decimal by multiplying by 10 so that this point comes here. So when you multiply by 10 on the denominator, you multiply by 10 on the numerator to balance. So here the point will move one step to the left. So we have 0.04 divided by 2. And 0.04 divided by 2 will give you 0.02. Okay? That would be the answer. It's as simple as that. Or you might as well say, okay, I'm writing this as a fraction. It becomes 4 over 1000. So it's divided by, this as a fraction becomes 2 over 10. Now you divide a fraction by a fraction. So what happens is that you will have 4 over 1000 multiplied by 10 over 2. That's the procedure. You change the division to multiplication and you turn this fraction upside down. When you divide by a fraction, that's what you do. You change the division sign into multiplication and flip this one. So now you can say, okay, for 2 goes once in here and twice in here. 10 goes once in here and goes 100 times in here. So you have 2 times 1, which is 2, over 100 times 1, which is 100. So 2 divided by 100 is like 2.0, so the point will move to the left 1, 2 steps. So you'll put a 0 here in this position and a 0 there to make it fine. So you have 0.02. So you can approach it in those two different ways. Okay, so I'm happy. I think you are happy too. Now we are done with basic operation, so let's move on to another topic in our revisions. There are a few things I want us to look at. Let's look at simplification. How do you simplify? Let's call it question 3. It's question 3, simplifying. Simplifying mathematical expressions. Okay, simplifying. All right, how do you simplify mathematical expressions? We'll look at simplifying them by removing brackets. Let's say you have this one. Okay, let's say we have this one. What do you do? So if the question says simplify, that means you need to distribute this negative sign into the bracket. Simply, you need to remove this bracket. Okay, so it will be, we shall have this p. When you remove this bracket, you say negative times p here is going to be negative p. This negative times negative 3 here is going to be positive 3. Be careful. Negative times this negative is positive. Now there is 3 here. Or if you don't mind, you can say, I know there is 1 here, even though it's not written. So it's negative 1 times positive p is going to be negative p. Negative 1 times negative 3 is going to be positive 3. Okay? So now you have removed the brackets, but this has to be simplified because you have the like terms here. This and this are like terms. So p minus p is 0. So ultimately you have 0 plus 3, which is 3. So this expression is simplifies to 3. All right? I think it's straightforward. Let's look at this one. Let's look at this one. We have this one here. Let's say we have 10 minus 3, okay? 3q plus q. Simplify this. How do you do it? How do you do this? All right, so it's going to be equal to 10, but here negative, you can say, okay, I know there is 1 here. Negative 1 times positive 3 is going to be negative 3. Negative 1 times positive q is going to be negative q. Okay? All right? So what happens? Now you simplify. These are constants, so they can be simplified. 10 minus 3 is 7 minus q. So simply, this is this. Okay. Now let's look at this one. All right. This one is 5x minus 2 bracket x plus 1. Okay. What do you do here? Uh, you are simplifying, so you will have to remove the brackets. All right. Then we have this 5x. Here we have negative 2, okay, times x here is going to be negative 2x. Negative 2 times positive 1 here is going to be negative 2. Now, they are like terms. They are 1, 2, 3 terms. Positive 5x, negative 2x, negative 2. There are 3 terms in this expression. But these two are like terms because they have the same variable, x. So we have 5x minus 2x. So that becomes 3x. Then minus 2. Okay? So it's simplified like that. There is something that is happening here. When you have a negative sign immediately out of the bracket, you are aware that it changes this sign here. If this sign is negative, it will be positive. If it's positive, it's negative. If it's positive, it becomes negative. Just because there is negative outside the bracket. Okay. Now, we will have to look at uh, this one. 6d plus 3 bracket 3d plus 2. Okay, so simplify this. What do you do here? What do you do here? It's equal to, there is nothing we can do with this 6d, so it's 6d. Now here we have multiplication. Positive 3 times 3d is going to be positive 9d. Positive 3 times positive 2 is going to be positive 6. Okay? So this is, we simplify this, 6d plus 9d is going to be 15d plus 6. So it's simplified like that. Okay? Now, that is basically how we simplify. Okay. Now we move on. There is something that I want us to look at immediately after this one. We are going to revise solving equations, solving linear equations, solving equations. We are just doing simple revisions. Remember, simple revisions. So we will just go through some topics and unravel the basics there. Okay. Let's say you have this problem. Um, it's 6x 6x plus 2 is equal to 8. Okay. Then the question says solve. When they say solve, that means you need to find the value of x. What is x? So by inspection, by mere looking at this, you can see that x is 1 because 6 times 1 is 6 and 6 plus 2 is 8. Okay? But how do you solve this? Okay, let's see how we solve this. The procedure says the term, this is the left hand side, this is the right hand side of our equation. So what you do on the left hand side, you must also do on the right hand side to balance the equation. It should be balanced because there is an equal sign here. So an equal sign means this side is equal to this side. So if you reduce this side with 2, you must reduce this one with 2 also to keep the equality here. Okay. So we have 1, 2, 3 terms. These 2 terms are constants. This one has a variable. We want to find the x here. So let's remove this term. Because it's plus 2, we will say minus 2. So that plus 2 minus 2 is 0. So because we have said minus 2 on the left hand side, we will have to have minus 2 on the right to balance our equation. So what we are going to do, plus 2 minus 2 is 0. So on the left hand side, we are left with 6x. Then our equal sign. So on the right hand side, 8 minus 2 becomes 6. Okay. So what do we do next? We have 6x, and 6x is the same as 6 times x. So we want to eliminate the 6 here so that we are left with x. So we just divide by 6 so that 6 cancels 6. Okay? So we divide by 6 on the left hand side. We must also divide by 6 on the right hand side to balance. So we end up dividing by 6 here just to balance. So the answer would be x equals to 6 over 6 is 1. So x equals to 1 is the solution. All right. Okay. Now, let's look at this one. Let's look at this one. Let's say we have x over 3 is equal to 5 over 7. Solve. So if they say solve, that means they want you to find x. Okay. So how do you find the x here? What you do in this situation is x has been divided by 3. So to eliminate the division by 3, we just multiply by 3. So we'll say multiply by 3 so that this 3 cancels this one. Then we will have to multiply by 3 on this side to balance. Because what you do on the left hand side, you must also do on the right hand side to balance the equation. Now we have x equals to 5 times 3 is 15 over 7. So that is the answer. So x is equals to 15 over 7. You have solved the equation. Let's have this one. Let's have this one. You have 0.3y is equal to 0.9. Then the question says solve. How do you solve for this? You just realize that on the left hand side we have 0.3y. So 0.3 has multiplied y. So if we want to find y, because when it says solve, they mean find the value of y. That means we will say I divide by this 0.3 so that it cancels this one. Then I will divide by 0.3 to balance. Okay, so we have 0.9 divided by 0.3. So dividing by decimal number is difficult, so let's multiply by 10 to make it 3 to move this point here. So we'll multiply by 10 to balance. Okay, so what are we going to have is this point will come here, so we have 9.0 over 3.0. So the answer is 9 over 3, which is 3. Therefore y is equal to 3 is the solution. Okay, so that's basically how we solve. Okay, that's basically how we solve. Now we will move on to another important topic, and this one is factorizing or factorization, where how do we factorize? How do we factorize? Factorize. Okay, now let's say you have something like this. Ax plus bx. Then the question says factorize. What are you expected to do here? That means you have two terms. This is not an equation but an expression. It's a mathematical expression. Then you have two terms, ax and bx. But when you look at these two terms, you will realize that they have a common factor, x. They have x as a common factor. So that means we are going to factor out x. When we factor, we open the bracket. We take x out. So we are going to have this. We are going to say this is equal to x bracket. We factor out x. So we say x bracket. Then we are left with a plus b inside the bracket. We take x outside, we factorize, we factor out x. So then we put it outside the bracket, then inside the bracket we are left with other factors being a plus b. Why? Because if you say x times a, you are going to get ax. X times positive b is going to be plus bx. Okay, so you factorize. So how do you get these terms here? After having identified the common factor, you can divide each term by the common factor. So ax divided by x, x cancels x, so that is a. That is why we put a here. Then bx divided by common factor x, this cancels this, so that is b. That is why we have b here. Okay, now that is basically what is happening. Now we may have um, um, 3ax, okay, plus 6bx uh, plus 12ab. And the question says factorize. How do you do this one? How do you work out this one? It is not easy. It is not easy. But we can use grouping here. there is AB here. AB. AB. But these two terms, these ones, have a common factor x. Okay? Let's say we do this. Let's just say we do this. We say 3ax plus 12ab plus 6bx. All right? Now, I want us to split this because it looks like this has got a factor for this one and a factor for this one. Let's just split this. Let's see, how do we split it? Let's split it. 12 factors of 12 would be what? 3 times 4. Okay, 3 times 4. Okay, or we could say 1 times 6. Okay, 1 times 6. Or we could say 2 times 6, not 1 times 6. 2 times 6. Okay. Okay. I like 2 times 6. Let's say we have 3ax plus 6ab plus 2ab plus 6bx. So this is nothing. This, we have just split this 12ab into 6ab plus 6ab plus, no, it can't be 2 here. 6ab plus 6ab, yes. 6ab plus 6ab. 6ab plus 6ab, okay? Now, are we correct here? Are we correct here? We could have, say, we could have even uh, split it into um, uh, um, if we split it like this, that means we may have a common factor here would be what? Would be 3a, okay? 3a bracket x plus 2b, all right? What happens here? Here we have 6b, okay? 6b bracket a plus x, okay? You see? So it didn't go to where I wanted. I wanted us to have, these two brackets the same. We can make these two brackets the same, okay? We can make the two brackets the same. Let's try. We break this 12ab such that when we factorize this pair, okay, and this pair, we get a common factor. Okay? Let's see again. So we can break 12 into, let's see, we can break 12 into, say, we can break 12 into 8 plus 4. Okay? What if we have 8 plus 4? 8 plus 4, 8 plus 4, let's see. If we have 3ax plus, okay, 4 doesn't work here, okay? Let's we break 12 into what? Should we break it into 9 plus 3? Let's say we have 9ab plus 3ab plus 6bx. What would happen? Let's see. When we factorize this pair, this one, we would have 3a as a common factor, then x plus b. Okay? What about here? Here we would have 3a as a common factor out, yeah? And then here we'd have 3b. Is that so? Yes, it's 3b here. Yeah, it's 3b here. Here we would have, when you factorize this one, what we have? We would have 3b bracket. Then here we would have a plus what? A plus 6x. No, 2x. So the two brackets are not the same again. Okay. Now let's check again. Let's check again. We can break 12 into, this is this, and then it could be 12 into, what do we break 12 into? 12 into 7 plus 5. No, 7 plus 5 won't work. 7 plus 5 won't work. 7 plus 5 won't work. 7 plus 5 will not work for us. So let me see again. Let's break this 12 into 12 into 10 plus 2. Will 10 plus 2 work? 10 plus 2. Let's see. 3ax plus, no, 10 is far. 10 is far. 10 is far away. Is far away. 10 is far away. 10 is far away. 10 is far away. Okay, let me just leave this one. I will work it out on my own, and then maybe later on we will, in our next revision, I will come back to this number, because I want us to factorize it by grouping. But because I'm in the video now, I will come back to this one. I will come back to this one. What we can do, okay, let me just leave it. I will come back to it. I would pause and work it aside and then come back. Let's see what we can do. Let's see what. All right. It looks like you will just stop here. Yeah, you can just stop here. You can just stop here. It doesn't matter, because either ways, it doesn't give you the same bracket here. I've tried the 3 ways. It doesn't give you the same bracket here. Maybe just because you are at grade 10, not grade 11, it doesn't necessarily have to give you that bracket here. So you can just split this one into this, okay, and then factor out the pairs 1, 2. You factor them out. 1, 2. You factor them out. It's okay. All right. Yeah. So we will move on now to something else. So for you, you just stop here, okay? Stop here. Yeah. Now we'll just move on to the last one, the last part here, the last part of our revision concerns the perimeter. Okay? Perimeter. So when we talk of perimeter, we are talking about the distance around a shape. When you talk of perimeter, we are actually talking about the distance around a shape. All right. So if we are saying Uh, the perimeter of a square the perimeter of a square is the perimeter of a square is the perimeter of a square is 12 centimeters. Okay? Then we are saying find its area. What would you do? How would you approach this simple question? Okay? The perimeter of a square is 12 centimeters. Find its area. How would you approach it? So a square has a four-sided polygon, and we know that the four sides of a square are equal, and there is 90 degrees here. Okay? Now, if they say the perimeter of a square is 12 centimeters, that means when you add the four sides of the square, you get 12. So to get the length of one side, you would just divide 12 by 4. 12 centimeters by 4, then you will get 3 centimeters. So that means each side is 3 centimeters. All right? Now, the question says, what is the area of the square? Now, to find the area of a square, you just say area equals to side by side. So you multiply side by side. So in this case, we are going to have 3 centimeters times 3 centimeters. So centimeter by centimeter will give us centimeter squared. Okay. Now 3 times 3 is 9. So the area of that square would be 9 centimeters squared. All right. So this brings us to the end of our revision session.